Let's talk about dimensional analysis. It's a very important skill in science. It helps you convert units, it helps you do stoichiometry and chemistry, it'll help you in physics. So it's very important to learn this skill and to get good at it. Okay, it works off of something called conversion factors. And a conversion factor basically just equates two different things that are in the same dimension. For instance, if we're talking about money, $1 is equivalent to 4 quarters. And 10 dimes is equivalent to, you could say 4 quarters as well, or you could say 20 nickels. There's a bunch of different ways you can compare all of these different units that have to do with money, if that were a dimension. Another example is, what if it's distance? You could say 1 meter is 1,000 millimeters. That's also equivalent. Or you could say 10 centimeters, or 10 millimeters is equivalent to 1 centimeter. That's another one. So anytime you can make these statements that each thing is equivalent to another thing, even if they have different units, because we're using numbers to make them equivalent, we would say that you can use them as a conversion factor. So let's just do an easy problem, and I'll show you the steps, and then I'll tell you each step individually, and you can write them down and keep them in your notes so you can understand it. Now, these are going to be some easy problems just to start out, just one or two. And, you can do these in your head, I know, but the whole idea is to have an easy problem so you're really not having to think about the problem. You're thinking about the steps and learning the steps to be able to solve more complex problems. So let's say we want to convert 3 meters into centimeters. Well, let me show you where the conversion factor would come in. So the first step when you're doing dimensional analysis is you want to write what's given, which would be 3 meters. The second step, you're going to set up your conversion factor. I call this the times fraction bar step because there's a multiplication symbol and a fraction bar. Then you're going to bring down the unit from the previous term into your new conversion factor in the denominator. And then you simply ask yourself, step 4 is the only step that you really got to think. It's, well, can I go right to centimeters? Is that easy for me to do? And it absolutely is. So we put centimeters here. Here is the conversion factor. You just remember that 1 meter is 100 centimeters. And this right here is what the conversion factor portion of this system is. And you can daisy chain these conversion factors up. We could have many of them if we want to convert to other things within the dimension of length or distance. So let's go ahead and solve this. So 3 times 100 is 300. Meters times centimeters is meters times centimeters. And you might find that strange, but you treat variables just like you treat numbers in these mathematical problems. And on the bottom we have 1 and we have meter. Now, normally you don't expand all of this stuff when you're doing these types of problems because it just is more to write. But for the purpose of you understanding how this whole system works, I expanded this. So what ends up happening? Well, you see meters is divided by meters here, and meters divided by meters equals 1. And 1 times anything is the same thing. So that's why we can say, well, cancel this out. Meters over meters cancels out. So then we're left with 300 centimeters on top and 1 on the bottom, which we know is the same thing as Anything divided by 1 is just the same thing, 300 centimeters. This is the way you do it. Now, I know this was a simple problem. Let me give you a problem to try. This will jump right in. How about this? If you're around, let's say a person's 16 years old. I want you to tell me how many milliseconds old they are. Ready, go. You might want to pause the video and try to figure that out. Time yourself and see how long it takes to figure it out. Okay, now you're back. And how long did it take you? Did you have to sit and scratch your head for a while? Did you feel the gears spinning? Were you putting in a lot of effort to try to think this thing through? Well, if the answer is yes to any of that, then this is a really good skill for you to learn, because 99.999% of people can't just do this automatically in their head. So here's what you do. Let's follow the steps that we said earlier. We'll start on a new screen. We'll write what's given, 16 years. And we set up our conversion factor. We bring down the unit. That's the third step. The fourth step, we got to think a little bit. And here's where you say to yourself, do I go right from years to milliseconds? That would involve a lot of thinking. I mean, if we could do that, then we wouldn't need to do the dimensional analysis. But guess what? It's really easy to go from years to days. You see, I know that a conversion factor is 1 year equals 365 days. Or I could have said a year is 12 months, or I could have said a year is 52 weeks. Whatever you want to do, however you want to do it. In this case, I did that. I'm going to continue. I told you could daisy chain these conversion factors, so I just start another conversion factor. Times fraction bar step is what I call it. Here's the next step. Step 3, you bring down the unit from the previous term. Again, I'm not going to go to milliseconds. That's too tough. I'm just going to simply go to hours. That's very easy to go from days to hours. I'm going to continue my chain here. And I'm going to bring down this unit down here. You see how this is just a skill. It's like a little trick, and once you learn it, it stays with you, and it makes these types of things very simple. I'm going to go to hours to minutes. I'm going to go from minutes to seconds. And then finally, I'm going to go from seconds to milliseconds. Then you go back and make sure you put the numbers in the right place. Students often mess this step up, and they'll say 365 years is 1 day. That doesn't make any sense. That's not true. But 1 year is 365 days. So make sure you don't mess up this part, and you put the right number by the right unit to make it equivalent. 1 hour, 60 minutes, 1 minute, 60 seconds, and 1 second, if you remembered your metric prefixes, is 1,000 milliseconds. You go to your calculator and you make sure that you punch the numbers in right. 16 times 365. I like to hit enter between each term so I don't get confused. I'm not dividing by 1 because I know that's a wasted step. It's the same thing. Times 24, enter, times 60, enter, times 60, enter, times 1,000, enter. And I'm going to have 2 significant figures, so that's going to be 5.05 times 10 to the 11th power. 5.05 times 10 to the 11th power. Now, am I done? No, I've got to write the unit, milliseconds. Very important. Now, how am I just left with milliseconds? Well, you remember like the meters over meters canceling out. Years cancels out years, days cancels out days, hours cancels out hours, minutes cancels out minutes, seconds cancels out seconds. So we're only left with milliseconds, and we did all the math with the numbers. So then indeed we get that answer of 5.05 times 10 to the 11th milliseconds. I did say it was two significant figures, so this is going to round to 5.1 times 10 to the 11th milliseconds. Okay. Now, write down the steps so you can keep these in your notes and you can know how to do this in the future, and you'll get good at it, you'll memorize it, and everything will be great. Okay, so step 1, write the given. Everybody can do that. It's very simple. Look in the problem. You're looking for a number. You're looking for a unit, whether it's grams or volts or lumens or moles, whatever it might be. If you're doing chemistry problems, you're looking for a chemical formula also, whether it's an element or a compound. That's important. You want to write all that stuff down. That's the given. In our problem, 16 years was the given, so we'll just keep this going on so we can just kind of follow along with how we did the problem. All right, next step is what I call the times fraction bar step. Why do I call it the times fraction bar step? Because I say that in my mind while I'm doing the dimensional analysis, because it just keeps me going and I don't forget what to do. And it usually seems like if I draw a blank after I write the given, I'm like, oh yeah, times fraction bar. It'll get you out of a jam. And this is, the purpose of this is to it's setting up the conversion factor. That's the purpose of times fraction bar. So let's do that over here. Times fraction bar. So that step's done. All right, step 3. Step 3 is going to be bring down the unit. Bring unit from previous term to the denominator of your new conversion factor you made. Okay, so let's do that. This is the unit. Bring it down here. Very simple. All of this stuff is automatic. Everybody should get to this point without even thinking. And as a matter of fact, the next step, I call it the thinking step, because you actually have to think a tiny, tiny bit. This is called the thinking step, because you're asking yourself some questions. One question, this will make sense as I explain it with the problem. Where am I going? What ultimate unit are you trying to get to? You got to know that. Like here, if I was going from years to days, well, then that's exactly where I'm going. I'm just going to go to days and I'm done with the problem. But the problem didn't tell me to go from years to days. The problem told me to go from years to milliseconds. So I have to ask myself another question. What is the next simplest, I'm going to call this the next simplest step, call it a step, to get there. This is what I mean by that. If I'm going to climb a mountain, I'm not going to just jump and try to land at the top of the mountain. I mean, I could do that again and again, and maybe one day my legs would be strong enough and I would be able to get to the top of the mountain. But it would require so much effort, it's so tedious, so much work. It doesn't make sense. What I would do instead, what would be the easiest thing to do? Well, just to take a step, right? The journey of 10,000 miles begins with one small step. And that's what I'm talking about here. I'm not going to go from years to milliseconds. I'm not going to jump that mountain. Instead, I'm just going to simply take a step and go, well, I'll go from years to days. That was easy. You're trying to make your life easy. And that's that step. Okay, so then the next step, step 5, repeat steps 2 to 4 if necessary. 2 through 4 if necessary. If necessary. Well, was it necessary to repeat these steps in the problem above? Yes, because watch this. I'm not done here. I'm not in milliseconds, so I've got to go to step 2, times fraction bar. I've got to go to step 3, which is bring down days. I've got to go to step 4 and think a little bit. Well, I'm not going to go to milliseconds. That's like jumping the mountain to the top again. But I'm going to go from days to hours. That's a simple step. Back to step 2, times fraction bar. Back to step 3, bring down hours. Let me think a little bit for step 4. Minutes. Okay. Times fraction bar, step 2. Step 3, minutes. Step 4, I'll go to seconds. And notice that we find ourselves at the end of our journey because, oh yeah, I can go from seconds to milliseconds. That's easy because I remember that 1 second is 1,000 milliseconds. And you know that 1 minute is 60 seconds, 1 hour is 60 minutes, 1 day is 24 hours, and 1 year is 365 days. And we do all this, and I think the answer we got was 5.1 times 10 to the 11 milliseconds. Make sure you put the unit. That's very important. And then let's just write in the last step just to make sure that we are not neglecting any step. And step 6 was write in numbers and solve, right? Write in numbers. Be careful. Don't swap them. A lot of people write the wrong number. They would say 60 minutes is a second. That's not true. And solve. That's the last step. I hope that this was helpful. Please practice your practice problems, and you will become an ace at these types of calculations, and it will serve you well for the rest of your life. And I hope you have a great day.